far, we have concentrated on simplifying expressions. Recall that an algebraic expression is variables and numbers that are combined by mathematical operators. So what is the difference between an expression and an equation? In the example given, x plus 2 is an expression, while x plus 2 equals 5 is an equation. Notice the only difference is that the equation has an equal sign. An equation states that two expressions are equal in value. In the next couple of sections, we will be focusing on solving equations. To solve an equation means to find all possible solutions that make the equation hold true. Looking at this equation, we know that x must be equal to 3 in order for the equation to be true, because 3 plus 2 equals 5. Stating that x equals 3 is solving the equation. In order to find all solutions to an equation, we must isolate the variable. A variable is isolated when it appears by itself on one side of the equation. Notice in the equation given, before we solved it, x was being added to 2. But when you solve the equation, x was isolated on one side of the equation. In later equations, we are not going to be able to look at them to solve them. We must then come up with steps that we can use to solve equations. You can think of an equation like you do a scale. If you take away something or add something to one side of a scale, you must add or subtract that same amount to the other side in order for it to stay balanced. Remember, in order to find a solution to an equation, you must isolate the variable, or get it by itself. Let's look at this equation. What number is preventing x from being by itself? The positive 5. In order to get rid of a positive 5, we can add a negative 5 to it. A number and its opposite will always cancel each other, as they add together to give you 0. Now if we added a negative 5 to one side of a scale, but not to the other, it would not stay balanced. The golden rule of algebra is whatever you do to one side of the equation, you must do to the other. So I must add a negative 5 to the other side of my equation in order for it to stay balanced. We have now isolated x on the left-hand side. On the right-hand side, we have found that x equals negative 15 because negative 10 plus negative 5 is negative 15. The addition principle states that if the same number is added to both sides of an equation, the results on both sides are equal in value. Remember, our goal is to isolate the variable. In order to do that, we need to add the opposite of the number with the variable on both sides. Adding the opposite of the number with the variable will cancel that number out, as they will add to equal 0. With an equation, you can always check your answer to make sure that it is correct. In the last example, we said that x was equal to negative 15. Now that we know what x is, we can plug negative 15 into the equation to make sure that it works. Instead of x plus 5 equals negative 10, we will plug in negative 15 for x. Does negative 15 plus 5 equal negative 10? Yes, it does, so we now know that our answer was correct. Before we look at examples, let's write down some steps we can use to solve addition and subtraction equations. The first step will be to find the side of the equation that has the variable. Next, ask yourself, what number is preventing the variable from being isolated? We then want to add the opposite of that number to both sides of the equation. Now that you've isolated the variable, you always want to check your answer by plugging it back into the equation. In the first equation, the positive 14 is preventing x from being isolated. We will then add a negative 14 to both sides of the equation. On the left-hand side, the positive 14 and negative 14 cancel each other. On the right-hand side of the equation, negative 20 plus negative 14 is negative 34. So we have x equals negative 34. Now we can check to make sure that we are correct. Plug in negative 34 for x. Negative 34 plus 14 is negative 20, so we know our answer is correct. In the second equation, the negative 9 is preventing x from being isolated. Remember, we have to add the opposite of negative 9 to both sides, so we will add a positive 9 to both sides. On the left-hand side, negative 9 and positive 9 cancel each other. On the right-hand side, 56 plus 9 is 65, so we now have x equals 65. Now we will check our answer. 65 minus 9 is 56, so we know our answer is correct. In the last equation, the negative 18 is preventing x from being isolated. In order to get rid of it, we will add a positive 18 to both sides. Negative 18 and positive 18 cancel. On the right-hand side, negative 2 plus 18 is 16, so we have x equals 16. To check it, we will plug it back into the equation. Negative 18 plus 16 is negative 2, so we know that 16 is the correct answer. Do not let an equation written this way throw you off. Some students prefer to rewrite the equation with the variable on the left-hand side. Others prefer to just leave it the way that it is and solve it. Remember your end goal. You're trying to isolate the variable. The number that is preventing x from being isolated is the negative 82. So we will add the opposite of negative 82 to both sides. Adding a positive 82 to both sides will cancel the negative 82 and positive 82 on the right-hand side. On the left-hand side, negative 107 plus 82 gives us a negative 25. So we know that negative 25 is equal to x. Writing the answer this way is fine, but normally solutions are written with the variable on the left-hand side. So we have x equals negative 25. When we check our answer, negative 25 minus 82 does give us a negative 107, so we know that negative 25 is the correct answer. We have just learned that you can add the same positive or negative number to both sides of an equation to keep it equal. The multiplication and division principle states that if both sides of an equation are multiplied or divided by the same non-zero number, the results of both sides are equal in value. Suppose I stated that 3 times some number is equal to 78. How would you go about solving this? Most people would not take the time to guess what number times 3 would give them 78. Most would divide 78 by 3 to see how many times 3 would go into 78. Let's look to see how this would play out algebraically. In order to solve multiplication or division equations, we will do the opposite operation on both sides. So if the number with the variable is being multiplied, we will divide on both sides. If the number with the variable is being divided, we will multiply by that number on both sides. In the previous example, we posed the question, what number times 3 is equal to 78? Since 3 is being multiplied by the variable, we will do the opposite and divide by 3 on both sides of the equation. The 3's on the left-hand side of the equation will cancel. Some may ask why we can cancel 3 divided by 3. If you think about it, 3 divided by 3 is 1, and 1 times x just leaves us with x. So dividing by 3 does isolate x on the left-hand side of the equation. Dividing by 3 on the right-hand side of the equation gives us 26, so x is equal to 26. Remember, you can always check your answer. Plugging 26 back into the original equation, 3 times 26 is 78, so 26 is the correct answer. Let's look at the steps for solving multiplication and division equations. The first step is to find the side of the equation that has the variable. Next, ask yourself, what number is preventing the variable from being isolated? If that number is being multiplied by the variable, we will do the opposite and divide by that number on both sides. If it is being divided, we will do the opposite and multiply on both sides. Remember, always check your answer by plugging your answer into the original equation. Let's look at some examples of multiplication and division equations. In the first equation, we will need to get rid of the negative 4 by doing the opposite of multiplying negative 4, which is dividing by negative 4. We will divide by negative 4 on both sides of the equation. Notice that we did not change the sign. The reason being is that negative 4 divided by negative 4 cancels, since negative 4 divided by negative 4 is 1. On the right hand side of the equation, negative 20 divided by negative 4 gives us positive 5, so x equals 5. To check, we will plug it back into the original equation. Negative 4 times 5 does give us negative 20, so we know our answer is correct. In the second equation, we are dividing, so we will do the opposite, which is to multiply by 9 on both sides of the equation. On the left-hand side, the 9's will cancel each other. On the right-hand side, negative 14 times 9 gives us negative 126. Now we will check our answer. Negative 126 divided by 9 does give us negative 14, so we know we are correct. In the final equation, x is being divided by negative 18. We will do the opposite and multiply by negative 18 on both sides of the equation. We can then cancel the negative 18's. Next, negative 18 times negative 2 gives us a positive 36. Remember, we can write the answer with the variable on the left, so x equals 36. To check, 36 divided by negative 18 does give us negative 2, so we know that 36 is the correct answer. Remember, to solve addition and subtraction equations, we will add the opposite of the number that is with the variable to both sides. To solve multiplication and division equations, we will do the opposite operation on both sides. At this point, pause the video and try solving one-step equations on your own. When you're ready, play the video to check your answers. In number 1, we should have added negative 9 to both sides of the equation. The 9 and negative 9 cancels, and we're left with x equals negative 31. To check your answer, negative 31 plus 9 is equal to negative 22. In number 2, since the 14 is negative, we will add a positive 14 to both sides. Negative 14 and positive 14 cancel, and we're left with x equals negative 53. Checking our equation, negative 53 minus 14 does give us negative 67. For number 3, the opposite of multiplication is division, so we will divide by negative 8 on both sides. Negative 8 and negative 8 cancel each other, and we're left with x equals negative 9. Checking, negative 8 times negative 9 does give us positive 72. Finally, in number 4, the opposite of division is multiplication. Multiplying by 5 on both sides, the 5's cancel each other, and we're left with x equals negative 65. Checking our answer, negative 65 divided by 5 does give us negative 13. Sometimes there will be things that you can combine together on either side of the equation before you solve it. If you can combine any terms together before solving an equation, make sure that you do so. Treat each side of the equal sign as separate expression. On the left-hand side, ask yourself, is there anything that you can combine together? In this example, we can combine negative 3 and positive 15. Negative 3 plus positive 15 gives us a positive 12. Now we can rewrite our problem. There is nothing left that we can combine together on the left-hand side, but on the right-hand side we can combine together 22 and negative 4. 22 plus negative 4 gives us 18. Now that we have combined all that we can together on either side of the equal sign, we can rewrite our equation to be x plus 12 equals 18. Remember how we would isolate the variable. In order to get rid of the 12, we will add a negative 12 to both sides. Solving this equation, we get x equals 6. We can check that answer by plugging it back into the original equation. On the left-hand side of the equation, 6 minus 3 is 3, plus 15 is 18. On the right-hand side, 22 minus 4 is 18, so our answer of 6 is correct. In the second equation, there is nothing we can do to the left-hand side. But on the right-hand side, we can combine together negative 3 and positive 10x. Negative 3x plus 10x is 7x. Rewriting the equation, we now have 14 equals 7x. Remember, to solve this equation, we would need to divide by 7 on both sides. Dividing by 7, we're left with x equals 2. To check, we can plug x back into the equation. Negative 3 times 2 is negative 6, and 10 times 2 is 20. Negative 6 plus 20 gives us the answer of 14, so we know that x equals 2 is the correct answer. I'm sure that every math teacher you've had at some point has told you to show your work, and I promise there's a good reason why. It is very tempting with these one-step equations to do the work in your head, but know that in the next couple of sections these equations will get longer and more complicated. By showing your work now with one-step equations, you will be well prepared to handle multi-step equations.